Hello guys, have such a great day and a very great week. As you know, we've been working so far with the Cartesian plane, and with the Cartesian plane we have worked with functions. Using those two topics, we have worked how to get the solution of every function, and that every function has a relation that you can find into the x-axis and to the y-axis, finding as well the domain and the range. This new topic gives us a more detailed explanation of how to use all that data into a more specific real world situation. Alright, this topic is slopes and point slope form, which is a way to solve linear equations into variables. So let's see what it is for. What is the meaning of this sign? What do you think is this? You have seen it maybe before in the highway, any road, maybe? But does it mean icy road ahead? Steep road ahead? Curvy road ahead? Trucks entering highway ahead? What do you think, you guys? Well, the result is, or the meaning of this sign is steep road ahead. Alright, that means that it has an inclination, it has a steepness to it. So check this out. So what does this mean, you guys? What do you think it means? Well, this means that this image, or that the road is 7% of the slope of the road. It means the road drops 7 feet vertically, which is in the y-axis, for every 100 feet horizontally. Alright, so that's the steepness of this road, like it's shown right in here. Alright, so what is the slope? What do you think is the slope? The slope is the steepness of a line, so that means the slope is all the way down from here. It could go either way, to the left or maybe to the right, according to wherever you're going and the direction of it. So slope can be expressed in different ways. Slope should always have a rise, and it should always have a run as well. How do we calculate the rise and how do we calculate the run? First of all, let me tell you that the rise is the vertical change, which means that's the change in places or displacement in the vertical axis, which is the y, and the run is the change in the horizontal change, which is the horizontal axis, which is the x-axis. That's why we find this data. The vertical change is wherever my point 2, wherever I plot my point 2 minus wherever I plot my point 1, and we use it the same way in the horizontal change, which is x2, x1. What does this mean? Alright, you know that to be able to get coordinates, every coordinate has x and y. Alright, every single coordinate, it should have an x and a y to be able to find a plot. Well, what we do here is that we are just going to number them. It doesn't matter if it's on the right, on the left, or above, beyond, wherever you can find them. You just need to name them. x1 and the corresponding y1, x2 and the corresponding y2, according to the line that you get from there, like this one. Imagine that this is in the Cartesian plane, and we are plotting this very line right there. So it should have a starting and an ending. Wherever this point is plotted would be x1, y1, and wherever it is ending would be x2, y2. But it doesn't have to be this way. You can order them the way you want them, as long as in this formula, they don't change places. All right, if this is y2, below this one there should be y2. We could never have y2 minus 1 1 over x1 minus x2. That should never be possible, because remember, that is the difference between them. So with difference, we're getting only the data or the amount that is exactly in the middle. So this one is a line that has a positive slope, if it is going uphill from left to the right. That means that if you're climbing, for example, a mountain, all right, and in this case, this would be a slope that is a negative slope if it is going downhill from left to right, all right? So this means that if I'm going downhill instead of climbing that mountain in the same example. So we are going to determine the slope of a line. As I told you before, this is our Cartesian plane, and we are finding two spots right here. One is located in 4, 1, and the other one is located in -2, -2. All right. When given the graph, it is easier to apply the rise. Remember, the rise is in the y-axis, and the run, that should be in the x-axis. All right. So we're going to determine the slope of this line. Start with the lower point and count how much you rise and how to get to the other point. This is a way to do it. This should not be our preferred way to do it, because that in this manner we wouldn't have, or we won't have a procedure for it, so we're missing a lot of steps. All right. So what we're doing here is that we're going to measure the points. All right. So in the rise, we are locating that it rises 1, 2, 3 points until getting to the following one, to the one that we have right here. And in the x-axis, the run, we are running 1, 2, 3, 4, 5, 6, right? You agree? So that means that we have 3 rise, 6 run. Remember, the rise is always over the run, so 3 over 6 is 1.5, right? So that means that's the result of my slope. That's when I find my slope. But and I'm sorry, this slope is positive because you're climbing it. All right, you're going up along with from left to the right, remember. And the line keeps increasing. So to find the slope of a line that passes through the points -2, -2, and 4, 1, when given the points, it is easier to use the formula. All right. Now we are going to use the formula, which is a lot better. y2 is the coordinate of the second order pair. y2 is 1. And y1 is the coordinate of a first order pair, -2. So you're going to take this one as reference point. So it's 1 minus -2, like this. And the x's are 4 minus -2, which gives us the result of 1 plus 2 over 4 plus 2, which is 3 over 6 equals 1/2. So it is the same, you know, it is the same. But in the first example, we are not placing a correct procedure, because we are not naming each of the coordinates accordingly. So did you notice that example 1 and example 2 were the same problem written differently? Either way, the slope would be 1/2. You can do the problem either way. Which one do you think is easiest? All right. I believe you're going to say this is the easiest, right? But as I told you, the procedure is very, very, very important. So we are going to see now, we saw before how to get the slope. Now we are going to use another formula, which is the slope and the intersection point, where M is the slope and B is the point that intersects that slope. So imagine that we have any kind of point along any of the slopes that you might have. So the formula is y equals M, which is the slope, x plus b. Alright, but what do they mean? The following is the point that will intercept the slope, right? Again, what is a slope? A slope is the inclination, or is the line that goes up or goes down. Remember, positive slope is the one that the steepness is like if you're climbing this mountain, and the slope negative is the amount of slant or downhill, or however you want to call it, when you're going down. All right, so it has a change in y and it has a change in x, which is the rise and the run, and it gives us just one result. Now the intersection point is y equals mx plus b. Some more examples of slopes. This is cross-country skiing, for example, or when you're running, or when you're riding a horse over a very plain place. So in this case, the slope should be 0. We don't have here a steepness part. Positive slope is up the sky lift, like going up. Down the slopes is the negative slope, and when we have a complete vertical line, that's undefined slope. The slope is a line. The slope of a line is a number m which measures its steepness. So again, we can find several different ones. Like anywhere in our Cartesian plane, we can find it 0, 1/2, 2, depending on what you get, right? And check this out, this is -1/4 because you're going down. So we're going to see the point slope form. Point slope form is y minus y1 equals to mx minus x1, where m is the slope and x1, y1 is the given point. Alright, remember our coordinates, the ones that we have here. And again, this m means the slope. Okay, so how do we calculate it? So write the equation in point slope form. Imagine that my slope is 1/3 and I have the points -1, -6. Those numbers, these numbers are going to be given the same way your calculation for the slope will be given, right? So you're going to plug this data into the equation, which is y minus y1 equals to m times x minus x1. So y plus, remember, minus 6 is plus 6 equals -1/3, which is the given or the resulting slope, times x plus 1. So we calculate this ones, and we're going to get a resulting y equals, because we have to clear this number, we have to pass it to the right side, so I can have my y left alone in order to get to the following step. An x minus 1/3 x minus 5 2/3. And this will be in the slope intercept form.